Today, we will be discussing about cloud computing and the trends which led to the ultimate concept of cloud computing. For example, distributed computing, it started from distributed computing, then grid computing, then cluster computing, and then utility computing, which is a form of cloud computing. And then we will discuss cloud computing in detail. So first of all, what is computing? The process of utilizing computer technology to complete any goal-oriented activity. Now, for example, traditionally when we had to perform any task, we used only single machine. We give it the input, the machine processes it, and it gives the output. Now, what if the complexity of any problem increases? Then it becomes impossible for that single machine to process on that. So in that case, the solution was given to break that complex problem into smaller chunks and distribute those chunks across many machines having their own resources. Reading the formal definition of distributed computing, which says distributed computing is a group of computers working together as to appear as a single computer to the end user. This figure depicts the same which I discussed earlier. These are the individual machines having their own processors and memory. These are some of the applications of distributed computing. The distributed systems are the backbone of all of these technologies, including internet, ATM machines, vehicular ad hoc networks, as well as wireless ad hoc networks. These are some of the common properties of distributed computing. The first one is fault tolerance. How the fault tolerance is achieved in distributed computing. Suppose there are two machines. In case of the failure of one machine, the other machine takes over the processing. So the end user witnesses the small amount of or very negligent amount of downtime in the system. The second property is each node plays partial role. In the distributed systems, each node is responsible for its own processing. It doesn't care what is going through the other peer machines. The third property is resource sharing. In resource sharing, uh, each user shares the resources including storage, memory, and processing power of the system. Load sharing. In load sharing, uh, the complete load is distributed across many machines. For example, there are 100 number of tasks, so if, initiated from the host machine. Those tasks are distributed across different machines, so the load would be distributed. In that case, um, each machine would compute on those individual tasks and return the results back to the host machine. Now, distributed systems are easy to expand. By that means, the distributed systems can be scaled up or scaled down by adding or removing any number of nodes or machines. Performance. Parallel computing can be considered a subset of distributed computing. By parallel computing, the performance can also be increased. Is grid computing. Grid computing is almost the same as distributed computing, except that it gives the easy access to the end user, and it provides the interface to utilize the resources of the uh, distributed systems. Reading the formal definition, grid computing enables the virtualization of distributed computing and data resources such as processing, network bandwidth, and storage capacity to create a single system image, granting users and applications seamless access to vast IT capabilities just as an internet user views a unified instance of content via web. A grid user essentially sees a single large virtual computer Most of the time an analogy is given, uh, as we use the electricity we see, to turn the lights on we simply switch the button on. We don't care from where the electricity is generated and where the grid is located. So it's simply a form of distributed computing. Moving ahead, why there was a need for a grid computing. Now, uh, scientific and engineering problems are becoming more complex, and users need more accurate, precise solutions to their problems in shortest possible time. So when we used only single machine, those machines could have spent more time in solving the problem, but using grid computing, as the problem is scattered or distributed across many machines, the results can be achieved within shortest possible time. The other reason for the emergence of grid computing was exploiting underutilized resources. In most of the time in universities, the labs are underutilized, laboratories or labs are underutilized, in which while the class is running, at that time the computers are utilized. But when the class is not running in the classes, in the lab, then the computers are switched off. But those computers can be utilized by turning them into the grid. Who uses grid computing? These are some of the areas in which grid computing is used. For example, reactor applications, physics application, weather forecast or material characterization, crystallography, detection and modeling of natural disaster. These are some of the complex problems which needs distributed systems, or a network of grid computing to solve these problems. These are some of the types of grid computing. First of all, computational grid. It mainly focuses on high throughput computing and high performance computing, in which the focus is on how many tasks are being performed within a single second. In data grid, the major focus is on the storage of data and the data discovery, data handling, data publication, and data manipulation of large volumes of data. So main objective is to store and manipulate data in data grid. In collaborative grid, with the advent of internet, there has been an increased demand for better collaboration, such as advanced collaboration is possible using the grid. Many users across the world work on a single project using uh, the grid. Network grid. A network grid provides fault tolerant and high performance communication services. In network grid, each grid behaves as a data router between two communication nodes. Utility grid. This is the ultimate form of grid in which not only data and computation cycles are shared, but the software or just about any resource is shared. In utility grid, the services are used by the end user. Those services can be in the software form or in the hardware form, or utilizing the resources. For example, processor, storage, and network capacity. Computers are the group of servers and other resources that act like a single system and enable high availability, in some cases load balancing and parallel processing. Now, to achieve three main objectives of high availability, load balancing and parallel processing, the concept of cluster computing was achieved. Cluster, as it says, it is a group of homogeneous servers and resources. By homogeneous means, either we can make a cluster of storage resources or processing resources, or the memory resources. So the cluster, or the group of computers, would be any homogeneous kind of machines. The objective is high availability. By achieving this, how this objective is achieved: by replicating the machines. For example, there are two computers in a cluster. One is active and the other is passive, although it's turned on, but it's passive. In case of failure of that first machine, the control is directed towards the second machine. and by that means the end user experiences very negligence amount of downtime. How the load balancing is achieved? By splitting the programs across many machines. For example, the host machine, or there is master node and there are slave nodes. Master node is responsible for throwing the bigger problem or splitting the bigger problem into smaller chunks and throwing them towards the slave nodes. So master node, if master node has to complete 100 number of tasks, then it splits them into two groups. If there are two slave nodes, 50 number of tasks for each machine. This is how the load balancing is achieved. Likewise, parallel processing. If the smaller chunks of a bigger problem are independent of each other, those can be performed in parallel. This is the basic diagram or form of a cluster computer. There is a root node, or we can say master node, which is responsible for splitting the bigger problem or throwing it towards the slave nodes. So the smaller chunks will be thrown to the slave nodes, and each node will compute on them and then return the results back to the master node or root node. Utility computing. Utility computing is basically a service provisioning model in which a service provider makes computing resources and infrastructure management available to the customer as needed and charges them for specific usage rather than affiliate rate. Uh, the provider of service uses utility computing to provide the service to the consumer and charges them for their usage. That service can be related to any software, or can be related to utilization of any resource, like for example processor, storage, and network capacity. The word utility is used to make an analogy to other services such as electrical power. Utility solution, your perspective. Now consumer expects service procurement, service assurance, availability, contractor management, consultants from the provider, whereas the provider is responsible for infrastructure procurement, equipment maintenance, resource utilization, technology refresh, system admin, capacity planning. Whereas most of the time their negotiations keep on pricing, service level agreements, security, the consumer is mostly care about, and application sizing. These are some of the payment models. The first is flat rate. In this payment model, the provider charges the flat rate, or we can say the fixed rate. He charges the fixed rate from the uh, consumer of the services. Or there can be any other model, for example utilization time. The utilization time of resources, how much time the consumer has utilized the services, on that the provider charges them. Another model can be, for example, what kind of resources the consumer has purchased. These are some of the risks involved in utility computing world. Data backup and security. Data backup, the auto backup is deployed in the system, which is one of the risk in utility computing. Security, anytime the provider can access data without letting the consumer know. And the partner competency is one of the challenge for the provider as well. So are they capable enough to recover from the disaster or any mishap? Defining SLA is one of the challenge in utility computing. It's difficult to come on the consensus or mutual terms. So what's the difference between all these four concepts? The difference between all these four concepts is a little bit bigger, but still there are some differences. For example, in distributed computing and utility computing, the resources. In distributed computing, the resources are static, and in utility computing, the resources are elastic. By elastic, it means the resources can be scaled up or scaled down by adding or removing any number of resources, but that is not possible in distributed computing. It provides a static number of resources. And the difference between grid computing and cluster computing is that uh, the grid computing is scattered across many locations, geographical locations, whereas cluster computing is geographically connected by lane. By that means is located at a single location. A collection or group of integrated and networked hardware, software, and internet infrastructure called a platform. Basically, a provider uses utility computing and provides services to the uh, consumer. For example, those services can be software related or platform related or an infrastructure related. The end user can utilize the applications of the provider, or can use the platform provided by the provider to develop his own applications, and or use the infrastructure or the hardware resources. These platforms hide the complexity and details of the underlying infrastructure from users and applications by providing a very simple graphical interface or API. Cloud computing is amalgamation of all these concepts, uh, whether it's utility and grid computing, autonomic computing, web services, hardware virtualizations. These all mix up to come up with the idea of cloud. This is an official formal definition provided by US National Institute of Standards and Technology, which defines cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. For example, networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. So there is a minimal human interaction. Everything is provided through an interface. There are three models of cloud computing. The highest level model is software as a service. In this type of model, the consumer uses the provider's applications running on a cloud infrastructure. For example, well-known applications are Google Spreadsheets, Google Docs, Facebook, or Gmail. In second model, the platform as a service, the provider provides the platform to the end user to develop his own applications. Integrated development environments, databases, SQL Server, different kind of services are being provided to, which lets the consumer develop his own application. This is little bit more privileged model as compared to software as a service. The third one is cloud infrastructure as a service. This is the highly privileged model in which the user is provided with the network resources, storage resources, processing, and other fundamental resources, which the consumer can scale up or scale down as per his need. The well-known infrastructure as a service models are Amazon Web Services, Microsoft Azure, Google Cloud Platform, and many more. Types of deployment model. The first one is private cloud. The private cloud infrastructure is operated solely for an organization. The single organization owns the um private cloud. This is also called a single site data center. Public cloud. The cloud infrastructure is made available to the general public. For example, Google Docs or spreadsheets are provided by the Google to the end user. Hybrid cloud. The cloud infrastructure is composition of two or more clouds, private and community or public. For example, in case of cloud bursting for load balancing between two clouds, when the capacity of a private cloud increases or more capacity is needed, then we hire for the services of a third party. Community cloud: the cloud infrastructure is shared by several organizations and supports a specific goal. For example, Gmail, G Suite, um, which focuses on which gives the free of cost Gmail services to the educational organizations. These are some of the advantages of cloud computing: instant software updates, unlimited storage capacity. Uh, the user knows that he has the unlimited storage capacity theoretically. Increased data reliability: crash of hardware drive destroys valuable data. Universal information access, latest version availability, easier group collaboration, device independence. And some of the disadvantages of cloud computing: requires a constant internet access. uh, it doesn't work on slow internet connections. Features might be limited as per need of the consumer. Applications can be slow. Stored data might not be secured. Stored data can be lost. Not clear that you can run compute intensive high performance computing application that use MPI or OpenMP. So these are some of the disadvantages of cloud computing. Thanks.